What if the beginning was not where we thought it was? What if the story of creation, told for nearly a century, is not the full story? For generations, science has spoken of the Big Bang, a single blinding flash, a moment when everything that is and everything that will ever be surged out of a point smaller than imagination. Time itself was said to have started there. Space was born and matter began its long journey toward stars, toward galaxies, toward us. It was an elegant tale, a universe young, expanding, predictable. Every telescope, every equation seemed to affirm its truth. But then came new eyes upon the cosmos. The James Webb Space Telescope opened its mirrors to the ancient dark. And in its silence, the universe whispered something unsettling. Galaxies. Massive, luminous, intricately structured galaxies, too old to belong to so young a universe, too vast to have formed in the time allowed. The light of their stars stretched thin by billions of years, yet burning with a maturity that should not exist so soon after creation. The story of the Big Bang has not been undone, but it now trembles under the weight of what Webb has seen. If the first chapter of the universe is not where we placed it, then what is time? What is creation? And what came before? In the long history of astronomy, there are moments when human vision seems to pierce beyond its natural limits. Moments when an invention allows the species to see farther, to reach deeper, to ask questions that once belonged only to myth and philosophy. The James Webb Space Telescope was conceived as one of those moments. Its purpose was clear and almost audacious in its ambition. To look back toward the first light of the universe, to witness the cosmic dawn, when the first stars ignited in seas of hydrogen and helium, when galaxies began their slow and delicate weaving across the darkness. It was designed not merely to take sharper pictures than its predecessor, the Hubble, but to change entirely the kind of light humanity could capture. Unlike the Hubble, whose mirrors gathered mostly visible light, Webb was tuned to the infrared. Infrared light is the light of the ancient and the hidden. It is the glow stretched by cosmic expansion until it falls outside the range of human sight. To see the very beginning, one must look in infrared, for the universe itself has stretched and cooled over billions of years, pulling its earliest light into these longer, invisible wavelengths. That was Webb's gift. Its gold-coated mirrors, unfolding in the vacuum beyond the moon, were built for the singular mission. They would act as a time machine, not through fantasy but through physics. Every photon it captured had traveled across time, carrying with it the story of an age when stars were still children. The telescope was a masterpiece of human engineering. Its segmented mirror stretched more than 6 meters across, a golden honeycomb designed to fold into the rocket that would carry it into the heavens. Beneath it lay the sunshield, a vast kite-shaped sail of silver layers, thinner than paper yet stronger than steel in purpose. Its 5 sheets, spread wider than a tennis court, blocked the warmth of the sun, earth, and moon, keeping Webb colder than the vacuum of space around it. Only in such silence and cold could the faint whispers of infrared light be heard. The launch came on December 25, 2021, a day often marked by stories of light, renewal, and new beginnings. From French Guiana, an Ariane 5 rocket carried Webb upward. On board was not only a telescope, but the collective hopes of decades of labor. More than 10,000 scientists, engineers, and visionaries across NASA, ESA, and the Canadian Space Agency had given their years, their brilliance, their patience to this machine. There was no second chance. Unlike Hubble, Webb could not be repaired by astronauts. It was destined for a place too far, the second Lagrange point, a gravitational harbor nearly 1 million miles away. The journey to that point took weeks. As the telescope coasted outward, it unfolded like an enormous origami flower. The sunshield unfurled, its delicate layers tightening into place. The mirror's golden petals slowly spread, each locking into position with precision measured in microns. It was a choreography rehearsed endlessly on Earth, now executed perfectly in the silence of space. Every movement was a gamble, every success a quiet triumph. By January 2022, Webb had reached its destination. Suspended in the balance of Earth and Sun, it turned its gaze toward the deep sky. Its sensors, cooled almost to absolute zero, began to drink in the oldest light. The mission was no longer promise. It was reality. Scientists waited with a mixture of awe and terror. What would Webb reveal? The expectation was to see the universe's youth, to glimpse galaxies forming just a few 100 million years after the Big Bang. The models were clear. The cosmic dawn was predicted to be a slow, careful process. Galaxies should be small, fragile, chaotic in structure. The first stars should burn briefly, illuminating the dark before collapsing in supernovae. The sight would be faint, distant, and primitive. And then the images arrived. In July of 2022, the world saw them for the first time. Webb's first deep field, a window into a slice of sky no larger than a grain of sand held at arm's length. Yet within that grain, galaxies spilled forth in uncountable numbers. Spirals, clusters, arcs stretched by gravitational lensing. Light from 13.5 billion years ago shimmered across the detectors, colors richer than any telescope had ever shown. Some galaxies appeared so ancient that their light was born when the universe was less than 300 million years old. The scientists stared in silence. The predictions had not prepared them for this. The galaxies were not small. They were not fragile. They were massive, complex, and strangely mature. Some rivaled the size of the Milky Way. Yet they existed in an epoch when such giants should not yet have formed. The universe, it seemed, had been busy. Far busier, far faster than the theories had ever allowed. Astronomers from across the world began to analyze. Teams from NASA, from the European Southern Observatory, from universities scattered across continents poured through the data. The Canadian Near-Infrared Imager revealed structures hidden within the first light. Spectrographs broke apart the photons, showing signatures of heavy elements, carbon, oxygen, even nitrogen, appearing shockingly early. If these galaxies contained such elements, then stars had already lived and died in rapid cycles, seeding the cosmos with the building blocks of life. The shock deepened. Not only were these galaxies too big, they were too old, too evolved, too chemically complex. The early universe, once thought to be a gentle dawn, looked instead like a sudden blaze. Something about creation was different. Something about time itself felt altered. The Big Bang still held as the leading theory, cosmic background radiation, first mapped by satellites like COBE and WMAP, still painted its faint echo across the universe. But the neat picture of a slow unfolding now trembled. The Webb had shown a cosmos more restless, more urgent, more mysterious than expected. The astronomers who had dreamed of witnessing the first sparks of starlight now stood in awe at what they had truly seen. And the world was reminded of a truth that haunts every age of discovery. Each time humanity believes it understands its beginning, the universe reveals that the story runs deeper. In the vast theater of science, theories are not merely explanations. They are frameworks of reality, scaffolds upon which generations of thought and discovery rest. For nearly a century, the Big Bang had been that framework. It was the story that gathered together the evidence, the expanding galaxies, the cooling radiation of the cosmos, the ratio of hydrogen and helium that filled the interstellar void. It was elegant. It was powerful. It was, for decades, unshakable. And then came the light from Webb galaxies glittering in the first few 100 million years. Not wisps, not scattered clouds struggling to take shape, but grand structures, some resembling spirals already ordered, already ancient in appearance, too massive, too luminous, too evolved. This was not what the models had promised. According to the standard timeline, after the Big Bang there was an age of fire and fury known as inflation. In a fraction of a second, the universe ballooned outward, stretching quantum ripples into the seeds of galaxies. Then came the cooling, the recombination, the long dark where hydrogen clouds drifted without stars. Only after hundreds of millions of years should the first starlight have pierced that darkness. Only after long ages of gravitational gathering should galaxies of real size have emerged. Yet Webb was gazing into that very period and finding something different. It was as though history had skipped steps, rushing ahead when it should have lingered. The so-called impossible galaxies defied chronology. They seemed to whisper of a cosmos older than the clock allowed. Cosmologists, accustomed to the steady march of consensus, felt the tremor. In conferences and journals, the phrase impossible galaxies began to surface. It was not meant literally, for the galaxies were there, captured in gold and crimson light. It meant that, by the rules long established, their existence should not be possible. How could a spiral galaxy, with its intricate arms and billions of stars, exist only a few 100 million years after the supposed beginning? How could heavy elements like oxygen and carbon, products of stellar death, already be woven into their light? Such features implied generations of stars had already lived and died, yet the cosmic clock suggested there had barely been time for a first generation to form. The tension between theory and observation became a wound. For decades, the Big Bang had stood as the central pillar of cosmology. It was supported by three grand observations: the expansion of galaxies, first seen by Hubble in the 1920s, the faint afterglow of the cosmic microwave background, mapped in exquisite detail by Kobe, WMAP, and Planck, and the elemental abundance that matched predictions of a universe forged in fire. To challenge that framework was to unsettle not just astronomy, but physics itself. And yet the Webb data demanded attention. It was not a single image or an isolated anomaly. One by one, early release observations revealed more of these ancient giants. Each carried the same unsettling signature: mass beyond the models, structure beyond the timeline, maturity beyond expectation. At first, the reactions were cautious. Scientists are trained to resist excitement when data first appears. Perhaps the distances had been miscalculated. Perhaps the redshifts were misleading, caused not by ancient light but by dust or intervening effects. Spectroscopic confirmations would be needed, not just images. But as the months unfolded, spectroscopy did confirm. The light was truly ancient. The distances were real. The galaxies were where Webb had placed them, and they were every bit as massive and evolved as they seemed. The disbelief deepened into debate. Conferences that had long followed predictable rhythms suddenly filled with urgent questions. Could dark matter have collapsed into structures faster than thought? Could the physics of star formation be different in those early epochs? More efficient, more aggressive in building galaxies? Or was there something deeper, something in the very assumptions of cosmology that required revision? For some, the answer was to refine, not replace. They suggested new models of rapid starburst where primordial clouds, under the influence of dark matter halos, could ignite torrents of star formation far more quickly than in today's universe. Others proposed that the masses had been overestimated, that what looked like vast galaxies might in fact be smaller, more modest systems magnified by gravitational lensing. But even with these caveats, the problem did not vanish. The numbers still pressed against the limits of the possible. There was a quiet unease, a sense that decades of cosmology had been shaken, not destroyed but unsettled, as though a familiar floor had shifted underfoot. The Big Bang theory had survived challenges before, from steady-state models to oscillating universes, and had emerged stronger. Yet Webb's revelations were different. They did not deny expansion. They did not erase the cosmic microwave background. They did something subtler and perhaps more dangerous. They bent the timeline, distorted the neat picture, suggested that the story of creation was stranger than even the most daring imagination had expected. Among scientists, reactions varied. Some stood cautious, refusing to abandon a framework that had proven so powerful. Others leaned into speculation, whispering of new physics, of hidden forces, of corrections to our understanding of time itself. In lecture halls and observatories, the debates grew more animated. Was the universe older than the clock of the Big Bang implied? Had the models of inflation missed a key element, a hidden accelerator that rushed galaxies into being? Or had human understanding of gravity and matter faltered at the edge of the beginning? It was not panic. It was something more profound. It was the recognition that science is alive, that no theory, however grand, is immune to the weight of new evidence. The Webb telescope, in its silence, had reminded humanity that the cosmos is not bound by expectation. It unfolds in mystery and surprise, in revelations that unsettle and expand the human mind. In the quiet of observatories, in the glow of computer screens filled with Webb's images, astronomers felt both shock and wonder. The universe was stranger than they had been taught. And in that strangeness lay both danger and beauty. Danger, because it threatened to undo the comfort of certainty. Beauty, because it promised that the story of creation was far from complete. The revelations of the James Webb Space Telescope were not confined to a handful of dazzling images. They were only the opening act. What followed was a deeper investigation, as humanity's most advanced eye began to peel back the layers of cosmic history with a precision no instrument before it had possessed. Infrared light was Webb's true gift. Where Hubble saw the visible cosmos, brilliant and immediate, Webb reached for the invisible, Infrared light travels where visible light cannot. It passes through clouds of interstellar dust that have long obscured the view. It carries with it the faint glow of the earliest stars and galaxies, light stretched thin by the expansion of space itself. What had once been hidden now shimmered into focus. Through that lens, the tapestry of the early universe transformed. Where Hubble had revealed thousands of galaxies in its deep fields, Webb unveiled tens of thousands. Galaxies that Hubble could only suggest as smudges appeared with form and detail. Shapes emerged where once there was blur. Colors unfolded where there had been shadow. The difference was not merely resolution. It was revelation. Statistical studies began to emerge. Teams of astronomers pored over the data, not just marveling at the beauty of single galaxies, but counting, cataloging, measuring. The numbers spoke with a clarity that shocked the field. There were far more galaxies in the early universe than models had predicted. Not only more in number, but more massive, more organized, more evolved. The universe at 300 million years old looked suspiciously like a universe already, billions of years into its story. The star formation rates were astonishing. Spectroscopy revealed torrents of new stars igniting in violent bursts, rates 10 or even 20 times higher than what had been considered normal for such young galaxies. The light from those stars carried chemical fingerprints, the spectral lines of heavier elements, oxygen, carbon, nitrogen, the products of stellar death, returned to the interstellar medium and forged again into new generations of stars. By rights, there should not have been enough time for such cycles of birth and death to have occurred. Yet Webb's data insisted otherwise. It was as if the cosmic clock had been accelerated. As if the universe had rushed to build galaxies, stars, and elements with an urgency that defied the slow, measured pace imagined by cosmology. The comparison to Hubble was striking. For decades, Hubble's deep fields had defined the frontier of the observable universe. In tiny patches of sky, it had shown humanity that the cosmos was filled with galaxies. Billions upon billions of them. It was a revelation that reshaped the human sense of scale. But Webb went further. Where Hubble had reached back 13.2 billion years, Webb pressed deeper, to 13.5 and beyond. Where Hubble's instruments blurred into uncertainty, Webb's infrared gaze sharpened. Where Hubble could not penetrate the veil of dust, Webb passed through with ease. The effect was like opening a locked door. Behind it lay a universe far richer, far older in appearance than anyone had expected. The investigations did not stop at counting galaxies. Astronomers began to analyze their shapes, their sizes, their organization. Some were compact and brilliant, blazing with intense starbursts. Others showed hints of ordered structure, disks and spirals already emerging in epochs when chaos should have reigned. The gravitational assembly of such systems should have taken far longer. Yet there they were, spiraling in the dawn of time. The shock of these observations deepened as the statistical studies accumulated. It was not a case of one or two anomalous galaxies. It was an entire population. Dozens, then hundreds of early giants filled the datasets. The impossible galaxies were not rare exceptions. They were common, even abundant. The universe had not simply produced a few outliers. It had systematically defied the predictions. This flood of evidence demanded new interpretations. Some argued that perhaps the models of star formation underestimated the efficiency of those first stars. If early stars, so-called population 3 stars, were far more massive and burned far more quickly than expected, they could have enriched the universe with heavy elements in short order, paving the way for galaxies to appear mature at astonishingly young ages. Others proposed that the nature of dark matter itself might hold the answer, collapsing into halos more swiftly and providing gravitational wells deep enough to gather matter with unexpected speed. But explanations strained. Every new dataset seemed to widen the gap. Even the brightest optimists acknowledged that the early universe was far more dynamic than the neat models had allowed. The comparisons to Hubble highlighted just how transformative Webb had become. Hubble had given humanity a vision of grandeur, but also of limits. It had shown galaxies as fragile infants, faint and irregular, slowly taking shape. Webb shattered that illusion. It showed galaxies as restless giants, forming almost as quickly as the universe itself. The deeper investigations carried with them philosophical weight. If galaxies were so massive and mature so early, what did that mean for the story of creation? Was time itself experienced differently in those epochs? Had the equations of cosmology, trusted for generations, missed something profound? Or was it humanity's understanding of physics, gravity, matter, the very fabric of spacetime that was incomplete. The numbers refused to be ignored. Star formation rates that should have taken billions of years compressed into hundreds of millions. Chemical compositions that implied cycles of birth and death far earlier than thought possible. Galaxy counts that swelled beyond prediction, suggesting a universe more fertile, more crowded, more urgent than science had dared imagine. With each paper published, with each conference presentation, the weight of Webb's findings grew heavier. The cosmos had revealed not only its beauty but its defiance, and in that defiance lay the seeds of a deeper mystery. The deeper Webb looked, the clearer it became. The story of the beginning was far more complex than humanity had believed. The Big Bang had not been undone. Its echo still filled the skies and the microwave background. The universe still expanded, still carried the fingerprints of its fiery birth. But the timeline, the pacing, the unfolding of structure, these were now questions without answers, and so the deeper investigation continued. Infrared light, sifted through golden mirrors, carried whispers from an age beyond memory. Every photon Webb collected was a messenger, a fragment of a story that refused to fit the script. The universe, revealed in sharper detail than ever before, was no longer simply expanding. It was resisting neatness, resisting certainty, resisting every attempt to bind it to the limits of human imagination. The first revelations from Webb were enough to stir unease, but as its golden mirrors continued to drink in ancient light, the puzzle deepened into something stranger, something far more unsettling. The galaxies that shimmered in Webb's gaze were not only massive. They were not only organized, displaying the symmetry of spirals and disks far too soon. They carried within them the unmistakable fingerprints of heavy elements. Spectroscopy revealed their secrets. Lines in the spectrum betrayed the presence of oxygen, carbon, nitrogen. Even traces of iron, the ashes of stellar death, gleamed in the faint light that had traveled for over 13 billion years. These elements should not have been there so soon. They require stars to live and die, to explode in supernovae and scatter their remains into the interstellar void. They require not one generation but several. Yet in the first few 100 million years after the supposed birth of the cosmos, these galaxies already shimmered with the chemistry of maturity. Gold itself, so rare upon Earth, so treasured in human history, was born in the collisions of neutron stars, in the titanic merging of stellar corpses. The presence of such elements in galaxies so young was a message. The universe had lived through cycles of creation and destruction, far faster than any theory had allowed. The cosmic dawn was no gentle beginning. It was a furnace, a blaze that forged the ingredients of life long before there should have been time. And then came a deeper shock. At the hearts of some of these ancient galaxies lurked shadows darker than starlight could reveal. Massive black holes, objects of immense gravity, whose very existence in such early epochs should have been impossible. To grow a black hole of millions or even billions of solar masses requires time. A star must collapse. The remnant must feed, consuming gas and dust, merging with others, expanding its horizon until it becomes the titanic anchor of a galaxy. By every model, this process should take hundreds of millions, even billions of years. Yet Webb revealed quasars, galaxies lit from within by voracious black holes, already blazing when the universe was scarcely out of infancy. These ancient black holes burned with ferocity, devouring matter and spewing jets of radiation across the cosmos. They were monsters, full-grown at an age when they should have been newborns. Their presence deepened the contradiction. How could such objects exist so early? How could gravity have sculpted such extremes before time had allowed the carving? The puzzle was no longer confined to galaxies. It extended to the very engines of creation and destruction within them. Galaxies and black holes, bound in a dance that modern cosmology insisted should take eons to mature, were already entwined at the dawn of observable history. The implications were profound. If galaxies were already mature, if elements were already abundant, if black holes were already massive, then the timeline itself was in question. Perhaps the framework of cosmic history, built on the assumption of a neat, linear unfolding from the Big Bang, was flawed. For decades, cosmologists had spoken of the universe as 13.8 billion years old. It was a number carved into textbooks, supported by the precision of satellites like Planck. which measured the cosmic microwave background with exquisite accuracy. But Webb's revelations suggested something discordant. The structures it revealed were not supposed to exist within that time frame. Either galaxies had found a way to race ahead of the clock, or the clock itself had been set wrong. Some scientists whispered of hidden mechanisms. Perhaps the laws of physics operated differently in those first moments. Perhaps star formation had been accelerated by conditions no longer present today, or perhaps dark matter, that invisible scaffolding of the cosmos, had clumped and collapsed in ways unaccounted for by the models, providing wells of gravity deep enough to build galaxies with unnatural speed. Others dared to entertain more radical ideas. What if the story of the beginning was incomplete? What if the structures Webb revealed did not emerge after the Big Bang but before? The thought was almost heretical. The Big Bang had stood for decades as the singular origin. Before it, by definition, there was no time, no space, no matter. But Webb's images pressed against that definition, hinting at a prelude. A chapter unwritten in the great book of creation. The unsettling possibility grew harder to ignore. If galaxies and black holes were already thriving so soon, then perhaps the Big Bang was not the clean birth once imagined. Perhaps it was a transition, not a beginning. A moment of transformation layered upon a deeper structure, an older foundation. Scientists, cautious as ever, framed their language carefully. They spoke of anomalies, of tensions, of models needing revision. But beneath the surface of their papers and presentations, a deeper unease lingered. What if the cosmic history humanity had built was not simply miscalibrated, but fundamentally flawed? The universe had always been a mirror as well as a mystery. Its vastness reflected humanity's longing for beginnings and endings, for origins that could be understood. But in Webb's revelations, the mirror fractured. The story of time itself seemed to bend. The neat chronology of creation unraveled into something older, stranger, more mysterious than science had ever dared to write. And so the mystery deepened. With every photon captured, Webb was not only showing what lay beyond the veil of dust and distance, it was whispering that the story of the universe was far larger than the framework humanity had trusted. Galaxies, elements, black holes, all conspired to tell a tale that reached beyond the Big Bang, into shadows where time and creation may have roots unknown. The puzzle was no longer just scientific. It was philosophical. It was existential. What is time if such maturity can exist at the dawn? What is creation if the beginning is not where it seemed? And what came before? The James Webb Space Telescope did not simply reveal galaxies and stars. It revealed questions that reached beyond the edges of science. Every image became a mirror, forcing cosmologists to confront the fragility of their own assumptions. If the universe was older in appearance than the clock allowed, then something in the story had to change. And so began a new age of speculation. The first attempts were cautious. Perhaps the Big Bang timeline was not wrong, but incomplete. If cosmic expansion had started earlier than calculated, then galaxies might have had more time to form. This did not require abandoning the Big Bang, only adjusting its clock. Some theorists suggested that inflation, that explosive growth in the universe's first fraction of a second, may have lasted longer, or begun from conditions not yet fully understood. Perhaps what Webb was showing was not a contradiction, but the subtle fingerprint of a different inflationary path. But such revisions soon felt unsatisfying. The galaxies Webb unveiled were not just slightly premature. They were impossibly mature. The revisions required to reconcile them with the standard model grew more strained. And so, deeper, bolder possibilities began to surface. Some turned to the echoes of an older idea, the steady-state universe. Long dismissed, it proposed that the cosmos has no beginning and no end. Instead of being born in a singular flash, it continuously renews itself. Matter created as expansion carries galaxies apart. While the discovery of the cosmic microwave background had buried this model decades ago, Webb's revelations gave it a faint new shadow. Could the universe, in some form, be older than its supposed birth? From there, speculation grew more daring. The cyclic universe emerged again, a vision where creation is not a singular event but a rhythm. In this view, the cosmos expands, cools, and then collapses back upon itself in a grand contraction, only to be born again in another explosion, a cosmic heartbeat pulsing endlessly through time. Each cycle would leave imprints upon the next, Subtle hints that a universe older than memory may lie beneath the one observed today. Roger Penrose, the Nobel laureate, had proposed a version of this vision he called conformal cyclic cosmology. In his model, the far future of our universe, where black holes dominate and even light loses its energy, becomes indistinguishable from the very beginning of another. The end and the beginning merge, one aeon bleeding seamlessly into the next. In this strange geometry of time, the Big Bang is not the origin, but the transition between cycles. If Webb's galaxies seemed too old, too mature, perhaps it was because they carried the imprint of a universe that had lived before. Others turned to the concept of eternal inflation. Inflation, once thought to be a brief spark, might instead be an endless process. In this vision, our universe is one bubble among countless others, each born from the froth of inflating space. Our Big Bang would not be unique, but local. Other bangs, other universes may burn unseen beyond the cosmic horizon. If so, then Webb's discoveries were not anomalies, but glimpses of physics shaped by a deeper multiversal landscape. Still others dared to imagine pre-Big Bang scenarios. Perhaps the singularity was never real. Perhaps time did not begin at zero but stretched back into a hidden past. String theory, with its tangled mathematics, offered visions of higher dimensions where universes might collide, birthing new realities in fiery events that resemble Big Bangs but are not beginnings at all. In such models, our cosmos is but one page torn from an endless book. Dark matter and dark energy also stepped into the speculation. These unseen forces, which together compose more than 95% of the universe, remain mysteries in themselves. If their behavior were different in the early universe, if dark matter clumped more quickly, or if dark energy shifted its strength, then galaxies might have formed with unnatural speed. Perhaps the answer did not require rewriting creation itself, only rethinking the invisible scaffolding upon which it rests. And then came whispers of quantum gravity. At the smallest scales, where space-time itself trembles, the known laws of physics collapse into paradox. Einstein's relativity and quantum mechanics, so powerful in their domains, refuse to join in harmony. If the beginning of the universe was governed by such physics, then perhaps the story is far stranger than even cyclic models or multiverses suggest. Some physicists imagine a foamy landscape of Planck-scale fluctuations, where universes emerge like bubbles from quantum tides. In such a reality, beginnings are illusions. There is only transformation, only emergence from the sea of possibility. Each theory carried its weight of speculation, each strained against the limits of what could be tested, and yet each shared a haunting implication. Perhaps the universe never began at all. This idea is not new. Philosophers have long wrestled with the paradox of beginnings. If time began, what came before? If creation has an origin, what birthed it? Science once seemed to provide an answer, the Big Bang, a singular beginning. But Webb's galaxies had reopened the wound. If they were too mature for their age, if they carried within them elements and black holes that defied the clock, then perhaps the clock itself was an illusion. Perhaps the universe is not a story with a first page, but an endless manuscript without beginning or end. The debates grew fierce. Conferences echoed with voices defending the standard model, while others cautiously suggested revisions or radical alternatives. Some clung to the power of the Big Bang, unwilling to abandon a framework so deeply supported by evidence. Others whispered that humanity might be standing at the edge of a new cosmology, one that would redefine existence as profoundly as the Big Bang theory itself once had. What united them all was wonder. For the Webb telescope had done more than challenge theory. It had reminded humanity of the humility required before the cosmos. No matter how confident the models, no matter how elegant the equations, the universe continues to unfold in ways that defy expectation. Its mystery deepens even as its light becomes clearer. Perhaps the Big Bang will endure, refined but unbroken. Perhaps it will be replaced by visions of cycles, multiverses, or eternal time. Perhaps the truth will be stranger still, written in mathematics not yet discovered, glimpsed in observations not yet made. For now, the speculation continues. Physicists wrestle with equations. Astronomers sift through data. Philosophers ponder the weight of beginnings. And the Webb, silent in its orbit, continues to gaze into the darkness, sending back photons that have crossed 13 billion years to reach us. Every image is a question. Every spectrum a riddle. Every discovery whispers of truths beyond the reach of certainty, and in the silence between those whispers, one haunting idea remains. Maybe the universe never began at all. The questions raised by Webb did not remain confined to wonder. They ignited a new campaign, a mobilization of science across instruments and disciplines. For the universe had spoken in riddles, and humanity now sought sharper ears, deeper eyes, and more powerful tools to listen. The Webb telescope continued its watch, suspended in darkness nearly 1,000,000 miles from Earth. Every week, it returned images of galaxies, nebulae, and stars that expanded the frontier of knowledge. But Webb was not alone. Even as it revealed the impossible galaxies, other observatories were preparing to join the effort, each with a different lens on the mystery. The European Space Agency's Euclid mission, launched in 2023, set its gaze upon the geometry of the cosmos itself. Where Webb looked at the distant past, Euclid mapped the present vastness. Its purpose was to chart the shapes and distributions of billions of galaxies, to measure the hidden hand of dark matter and the accelerating push of dark energy. By mapping how structure has grown across cosmic time, Euclid offered a companion to Webb's deep vision, one telescope unveiling the ancient dawn, the other surveying the present horizon. Together they traced the bookends of cosmic history, searching for continuity or contradiction between the two. Soon, the Vera C. Rubin Observatory will open its eyes from the mountaintops of Chile. Unlike Webb, which stares deep into narrow fields, Rubin will sweep the entire sky in a relentless rhythm, capturing it again and again. Every few nights it will record the whole heavens in exquisite detail. It will watch galaxies evolve, track the motions of stars, and catch the flicker of transient events, supernovae, collisions, the births and deaths of worlds. By creating the greatest time-lapse of the universe ever attempted, Rubin will not only complement Webb, but test the stability of cosmic models. If the early galaxies are truly too old, too massive, then Rubin's vast survey may reveal the fingerprints of how such anomalies evolved into the present-day universe. Together, these instruments represent not just curiosity but resolve. Science, when challenged, answers not by retreating into certainty, but by building new eyes to question deeper. Yet telescopes are only one part of the response. On Earth, in the silence of particle accelerators and underground detectors, another search is underway. For if the galaxies of Webb defy explanation, perhaps the answer lies not in the stars, but in the particles that shape them. The search for exotic matter and hidden energy continues with urgency. Dark matter, long hypothesized as the invisible scaffold of galaxies, has never been directly detected. Yet without it, galaxies cannot hold themselves together. Their stars would scatter into emptiness. If dark matter behaved differently in the early universe, if it clumped more efficiently, or if it carried interactions unknown to current physics, then galaxies may have formed with impossible speed. Experiments at the Large Hadron Collider, in subterranean detectors buried deep to escape cosmic rays, probe for such possibilities. Each collision, each flicker of anomalous energy, could hint at the unseen architecture of creation. Dark energy, too, remains a riddle. It is the name given to the force that drives cosmic acceleration, yet its nature is unknown. If its strength has shifted over time, if it pushed differently in the youth of the cosmos, then the pace of structure may have followed a hidden rhythm. New instruments designed to map cosmic expansion with unprecedented precision test this idea. The mystery of Webb's galaxies has given them new urgency. While telescopes watch and experiments probe, supercomputers attempt to recreate. In digital realms, scientists build universes of code, seeded with the known laws of physics. They let gravity tug, let stars ignite, let galaxies grow in the artificial dark of algorithms. These simulations are then compared to what Webb has revealed. Yet again and again the models falter. Even the most advanced simulations, run on machines that calculate trillions of operations each second, struggle to birth galaxies as old, as massive, as mature as those Webb observes. To match reality, the codes must be adjusted, the physics rewritten, the parameters shifted beyond their comfort. Every failure is itself a discovery. It tells scientists where their understanding falls short, where hidden truths still wait to be uncovered. The tension grows with every paper published, every dataset released. Do we adjust the current theory, stretching its parameters until it fits? Or do we embrace the possibility of a new paradigm, one that will redefine cosmic history from its roots? This is the edge of science, the place where humility and boldness meet. Humility, in admitting that the cosmos has spoken in ways not foreseen. Boldness, in daring to imagine models that defy the weight of tradition. The Webb telescope has shown humanity galaxies that should not exist. Euclid will map the scaffolding of matter across billions of years. Rubin will sweep the heavens in a ceaseless watch, catching every flicker of cosmic change. Supercomputers will build digital realities, testing every conceivable path of creation. Particle physicists will probe the invisible, searching for exotic matter or new forces that might explain the anomalies. Together, they form a chorus of inquiry, each voice tuned to a different register of reality. Together they press against the silence of the unknown, and still the question remains. Is this a correction to the standard story or the beginning of another? Are these galaxies a sign that the Big Bang must be rewritten, or a whisper that another framework altogether waits to be born? The instruments will answer slowly, with patience measured in decades. But the mystery will not fade. The universe, once thought to be neatly charted, is again a frontier. And humanity, armed with its telescopes, its detectors, its machines of thought, stands again at the threshold of wonder. From the dawn of thought, humanity has searched for beginnings. Every culture, every age has told stories of creation. Some spoke of gods breathing life into darkness. Others imagined cosmic eggs hatching universes from silence. Still others believed in cycles, in endless repetitions of birth, death, and rebirth. The longing was always the same: to know where it started, to know where we came from. Science in its modern age offered its own story. The Big Bang became the great narrative of creation, an origin not of myth but of mathematics. It was a tale woven from evidence: the expansion of galaxies, the glow of background radiation, the chemistry of the elements. For nearly a century it stood as the beginning not only of matter and light but of time itself. It was a story both majestic and humbling, an answer to questions once thought unreachable. And yet Webb has unsettled the tale. Its golden mirrors, unfolding into the cold of space, have caught light that seems to whisper of an older story. Galaxies too massive, too mature, shining with elements that should have taken longer to be born. Black holes roaring when there should have been only faint embers. The evidence suggests not a simple beginning, but a narrative already in motion, a page turned in the middle of a book humanity had assumed was the first. The emotional weight of this possibility is profound. For if the Big Bang is not the origin, then what becomes of the human need for a first moment? What becomes of the comfort in believing that all things emerged from a single spark? The loss of a beginning is more than scientific. It is existential. It confronts the deep yearning for boundaries, for edges, for clarity in a universe that may offer none. Time itself becomes a meditation. Is it linear, with a clear birth and inevitable end? Or is it cyclical, an eternal wheel where beginnings are illusions, each aeon folding into the next? Is the universe finite, a single story with a last page? Or eternal, with no first line and no final word? The Webb telescope in its silence leans toward the eternal. Its images suggest continuity rather than commencement, depth rather than surface. If galaxies existed before they should, then perhaps time is not a straight arrow but a river, flowing from sources unseen, bending and branching in ways not yet imagined. Such reflections reach beyond science into the very nature of meaning. If the universe has no beginning, then existence itself becomes less about origins and more about participation. We are not products of a singular event but fragments of an eternal process. We are not witnesses of the first light, but companions in an unending dawn. The Webb telescope is not only a machine of mirrors and sensors. It is a symbol. Suspended in the infinite night, its golden eyes gaze deeper than any instrument before it. It does not resolve the mystery. It deepens it. Every photon it collects is a reminder that certainty slips further away the more the universe is known. The closer humanity peers at the beginning, the more it finds only continuations. And so the narrative closes not with clarity, but with wonder. The Big Bang may not be the final word on beginnings. It may be a chapter, one turning in an endless manuscript, one page among countless that stretch before and after. The golden mirrors of Webb gaze into the abyss, and the abyss responds with whispers. Whispers of galaxies that should not exist, whispers of stars that burn too soon, whispers of black holes that roar before time allows. whispers that speak not of a single birth, but of a story without edges. Perhaps the beginning was not a bang, but a whisper that has always been echoing without end.